Now you know that there are two types of charges, and like charges repel each other and unlike charges attract each other. Now, what is the magnitude and direction of this force of attraction or repulsion between the two charges? Coulomb's law gives the formula to find the direction and magnitude of force between 2 point charges at rest. So let's see what is Coulomb's law. Coulomb's law. The force between 2 point charges is directly proportional to the product of charges and inversely proportional to the square of distance between them. And this force acts along line joining 2 point charges. Thus, Coulomb's law gives the method to find the force between 2 point charges. Consider 2 point charges Q1 and Q2 are separated by a distance R. The magnitude of force between these two charges, magnitude of force is directly proportional to product of charges and inversely proportional to square of distance between them. So we can write magnitude of force is directly proportional to Q1 Q2 by R square. If we replace this proportionality sign, we can write F is equal to K Q1 Q2 by R square, where K is proportionality constant and the value of K depends on medium between the two charges. It means that when these two charges are placed in free space or vacuum, the value of K is different. If there is a plastic sheet between the 2 point charges, the value of K will be different. So the value of K depends on medium between the 2 point charges. Suppose there is a free space between 2 point charges. For free space, K is equal to 1 by 4 pi epsilon 0, where epsilon 0 or epsilon naught epsilon naught is called permittivity of free space, and its value is epsilon naught is equal to 8.85 into 10 to the power minus 12 coulomb square Newton per meter square. Per Newton per meter square. If we put the value of epsilon naught in this equation, value of pi, we get value of k is equal to 9 into 10 to the power 9 Newton meter square per coulomb square. You should remember this value. Now we have the formula of magnitude of force between 2 point charges placed in free space separated by distance r. We have this formula can also be written as F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. This is the formula of magnitude of force between 2 point charges. Here this is the magnitude of force. So the sign of charge is neglected. You should not write the sign of charge. If they are opposite charges, the force will be attractive. If they are like charges, the force will be repulsive. So we have formula when 2 point charges are placed in free space.